right? So first, second, third period. Third period is right there, P sublevel. Now, we know from the other day that this is P1, P2, P3, P4, P5, and P6, right? Now, if it says half filled, we know how many will fill a P sublevel. 6 will fill the P sublevel, right? So what's a half filled P sublevel? 3. So P3 would put us at what element? Phosphorus. Okay? Make sense? Abraham, you're looking at me like, how on earth did Miss Wall get that? Huh? You remember? All right, so before you went to Russell, you remember your quantum numbers where we did the SPDF sublevel, and the S sublevel could hold 2 electrons, and then the P sublevel could hold 6 electrons. Okay, if you forgot that, you can count across P, and P has 1, 2, 3, 4, 5, 6 elements, and it has 6 elements because it can hold 6 electrons. Okay, so half of 6 is what? 3. Okay, so that's why we counted across 3. Okay, all right, number 2. Which element has the first electron in the F sublevel? So who's the first one in F? All right, so if we go to F, the first one in the F sublevel, this is F, right? So CE. Everybody got CE for that one? Okay. Number 3, how many dots does gallium have in its dot diagram? Since I just said how many, I didn't say where. I'm just looking for a number, right? What tells dots? What kind of electrons?
Outer shell.
You can say outer shell, or what's the other name I could use? Valence. Okay? Outer shell or valence, right? So if I get rid of this, all right, what's the pattern up here?
1, 2, 3, 4, 5, 6, 7, 8.
Okay. So gallium is here. So how many dots would it have?
3.
It'd have 3 dots. Okay? Outer shell electrons or dots. So you should know the pattern that we learned for outer shell or valence electrons. And so 3 tells you the dots. Everybody okay with that?
Yes.
Okay. And the last question, how many inner shell electrons does silicon have? How do we do that one? Inner shell electrons for silicon. What should we do there? 2 different ways you can do it. Give me something. Okay, that's one way. All right, so how many electrons does silicon have total? Okay, if you look on the periodic table, it has 14 electrons total. And how many does it have here in the outer shell? It has 4 outer. So you can subtract and get 10. Okay, that's one way. It's not the way that more people do it. Okay, it certainly works. What's another way you could do it? Jay, put your phone on my desk over there. Over there. Is that or an office? You can put it on my phone and have on my desk and get it back at 11:40, or I'm going to pick up the phone and call the administrator. Them's your options.
You always messing. Always.
I kept third periods to 3:30 in the afternoon yesterday. Thank you for being very cooperative. I appreciate it. All right, so what's the other way we can find the number of electrons? Somebody close that door. I'm making way too much noise in the hallway.
Can you draw that?
Draw the what?
That circle.
That's way too complicated. Way too complicated. I would draw less than the arrows. What's the shorter way? A little more than shorthand.
Like 2 pieces.
Yeah, I draw the electron configuration. So 1s2, 2s2, 2p6, 3s2, 3p2 if you wrote it out. Okay? Now, the reason I said I wouldn't draw the arrows is you don't actually need the arrows. You just need to know the total electrons. So what's the outer shell?
So the highest level.
The highest energy level. So
Yeah.
which one is the highest energy level?
3.
Okay, so this is the outer shell, which is how many? 4. And then that makes everything else the what? The inner shell. So there's how many here?
10.
2, 4, 6 is
10.
10. So there's 10 on the inner shell. And you'll find when we get down here today and we're doing a lot of the application questions, you will find it's helpful to do things like draw the electron configuration to answer the questions. Okay? Questions about how to do any of those 4.
Is this what's going to be similar to on the test?
On the test, yes, not the quiz today. The quiz today is just being able to navigate the periodic table that you color coded. Yes. Yes, but this is similar stuff you'll see on the test when we come back after break. Okay, and for any of you who weren't here yesterday, we said the test is on Tuesday when we come back because we'll finish everything probably today. I'm actually leaning towards doing a lab tomorrow. No, I shouldn't say that.
No, because I won't be here.
I know. It's an easy lab to make up, though. Okay? It's kind of a fun one to do, which is why I'm leaning towards doing it tomorrow. All right. I haven't decided yet. Questions? Anything before we do the quiz? Because the quiz is easy if you've done your studying. All right. You need something to write with, and that's it. Because I'm giving you your periodic table. So you don't need anything. Everybody got what they need? Something to write with? Pen, pencil, something? Put your stuff up.
Whoa.
Yes?
Marissa door is signing out.
Okay.
Thank you.
Welcome.
Alice.
All right, Marissa, you got one to make up when you get back.
All right.
All right. I put the periodic table on the back this time to save some of our periodic tables because we'll use quite a few of them when we did the unit on the periodic table. So I was just trying to save some paper for today because you really don't have to do a whole lot of labeling and marking up and flipping it around like you did yesterday. If you can't find something, just ask, and I will tell you where the element is so you're not spending the rest of your life hunting for it. One for Jade. You're
Do
gonna
you
do what?
count off for like spelling if it's off by like a letter or something?
No. No. If you spell something and it's off by a letter, no, I will not mark it wrong. Now, if it's not in the ballpark, yes. What's wrong, Salute? Okay.
Where's the millennium?
Say what?
Where's the millennium?
Let's see what you got, because I don't remember. Which? Where you at? Tellurian 52. Yes, ma'am.
Tiffany Fowler is on her way to class. She was in the main office.
Okay,
Thank you.
welcome. Apparently you eavesdrop and listen very well. I'm not sure that's a fabulous skill to have, though, but good job. Who's still working on the quiz? Got it. There were two names for that group. I won't get the other more time for them. You want to take your quiz or lunch so you don't feel so rushed? Okay. The lunch do you have? Third, that's fine. Who's still working now? I got Abraham. Is that it? So tell me when you're done, Abraham. All right, finish first to the front. How do you know you're not going to be here tomorrow? How are you?
Oh, that's right.
I'm not worried about it. I really am thinking about doing a lab tomorrow. It's an easy lab. It's fun.
Fine.
Considering some labs that we could do. Salt lab's hard. It just is. And this one is, you're going to figure out how many moles of chocolate takes to write your name on the sidewalk.
Yes.
Ridiculous.
It's an easy one.
Ridiculous.
I don't think yeah, that one's duplicated. Really? I think I duplicated that one. I thought you were done. Questions in the clicker and your review still working on quiz. What's wrong with it? Alright. Anything we didn't know on the quiz that we need to talk about? Nope, never mind. Tiffany's got to take it later. Scratch that. Alright. Find your notes. Let's finish up what we were doing yesterday so we can practice and apply some stuff. And I will probably have those in sometime later today because fourth period's working on a lab. Justice, put yours on my desk. Yeah, plug it in behind my desk. All right. So, yesterday, to review where we were at, I told you we'd re-summarize it, and then we were going to talk about reactivity. It's kind of small. Let's see if I can make this a little bigger.
This just review or is this new notes?
It goes with yesterday.
That's periodic.
Yep. I shrunk the transition elements. Like super small. Alright. So, this is group 1, 2, 13, 14, 15, 16, 17, and 18.
Righteous.
That's the D block.
Should we write this?
Yeah. I shrunk them super small. Okay, because we're not really talking about the D block at the moment. Good God. You got giant chunks missing out of this thing. Dang. I thought you were plugging this thing into charge.
I didn't have much.
Now, we want to summarize what we did yesterday and add on to it a little bit also. And then we're going to apply, hopefully, what we've learned, and we're going to do some review with it. Now, theoretically, if we weren't all getting out tomorrow for Easter break, we'd be ready to test by Friday or on Friday. So, unfortunately, with where Easter fell, it just isn't very convenient. So, has everyone had an opportunity to draw this?
No.
Remember, those of you who are going, I'm not drawing it. You're going away for 10 days and coming back. Okay? You're going to be expected to know all of this on a test on Tuesday. For some of you it is, because you will not have forgotten it on Tuesday. Some of you will be a blank slate when you come back Monday and go, hey, I don't remember any of this fall. It's not my problem. On Tuesday, we will test. Okay? Whether you remember it or not. Say what?
You gonna give us review sheets Monday like you always do?
I have a few, yes. I do. I don't have a ton. And we will do a little bit with it, yes. We will probably not spend the entire day reviewing. Now, what do we remember about group 1 yesterday?
They all have wonderful time.
Okay. Now, the easiest thing we should all be able to tell me from yesterday is the outer shell electrons. Everybody in the room should be able to do that without difficulty, right?
Yeah.
So they all have 1 electron, and then group 2 has, and group 13 has, and group 14 has, and 15, 16, 17, and 18. Now, we talked about yesterday how each group would go about achieving a noble gas configuration, right? And a noble gas configuration refers to what? What's a noble gas have? 8 electrons. So how are they going to get a noble gas configuration? All right, so group 1 will do what to get to that noble gas configuration? It will what? It will lose 1, okay? It will lose 1 electron. What will group 2 do? It will lose 2 electrons. What will group 13 do? It will lose 3 electrons. What will group 14 do? All right, it will lose or gain 4 electrons. What will group 15 do? It will do what? Don't say, we're starting to sound kind of pitiful out there now. All right, what will group 16 do? It will gain 2. In group 17, it will gain 1. And group 18, it will do what? It's full. So it's going to do neither lose nor gain electrons. Now, a general trend we should notice. If I ask you about metals, what should you tell me about metals? All right, where are metals at on the periodic table? All right, so I drew in my staircase. I just drew in some stairs. All right, where are metals?
On the left.
Okay, so metals are over here. Okay, so what do metals do with electrons? Heard it, the little weak voices out there.
Lose.
Metals lose electrons every day of the week. Okay? That's a general trend that we should notice based on what we did yesterday. Okay? You should be able to tell me that. Metals always lose electrons. Always. So, what would that mean about nonmetals then? Nonmetals will do what? That's right. Nonmetals gain electrons. Does that make sense?
Yeah.
Now, you should also at this point be able to tell me their oxidation numbers. What is group 1's oxidation number? +1. What is group 2? +2. What is group 13? Sorry, I meant group, I said 13. It's +3. Group 14. ±4. Group 15. -3. Group 16. Group 17. And 18. All right. Now, let me get rid of this mess I have right here, because I've emphasized what I wanted there. We want to talk about reactivity. Where on the periodic table are the elements the most reactive? Where are the elements the least reactive? Apparently, I'm just going to need to draw this. Because I'm making a mess. There. All right. So, where on the periodic table will the metals be the most reactive? Where on the left? Give me an actual group number or group name. I don't care which.
3.
Group 3 is a transition element.
Group 2. 1.
Group 1. Why would group 1 be the most reactive metals? Okay, group 1 are the most reactive metals. Okay, right there. Now, what'd you say? I couldn't hear you, Tomas. What'd you say?
Because it's easier to lose one.
Exactly. All right. It is the most reactive because it is 1 electron away from 8. It only has to lose that one electron, and it will have that magic number of 8. Okay? It just has to give that 1 electron away. So who would be the other most reactive group on the periodic table? 18 has how many?
17.
It has 8 already, so it's not going to be reactive at all. So who? 17. Okay? Group 17 are the most reactive non-metals. And again, they are 1 electron away from 8. Every year, people laugh at me when I use this description. Probably going to get fired one year from saying this. Okay? These are the Ho's on the periodic table. Okay? This group here is giving it away to any group that will take it. They're like, please, please take my electron. I'm giving it away free to anyone who will take it. I just need to lose this 1 electron. So I'm giving it away. This group down here just needs to do what? It has how many? It has 7. It only needs 1. So it's taking from anybody who is offering. They're not picky, okay? They will take it from anybody who is offering up some electrons. Okay? So it loves the people in this group. So when we talk about bonding, group 1 and group 17 love each other. They make very stable compounds, okay? Because this group wants to give away an electron, this group wants to gain an electron, okay? Why? They are each what? 1 away from 8. Now, who else would be really reactive on the periodic table? For the exact same reason. Now, as you go in towards the middle, what happens? They become less reactive. They become more stable. Now, who is the most stable or least reactive on the entire periodic table? 18. Why?
They're already there.
It already has 8. These are your old maids, your nuns. They got 8. They're not having it with anybody. They're not giving it away. Doesn't matter how much you ask. Okay? You got me? Don't get that mixed up on the quiz or the test. Questions? Now, we're done with stuff for the test. That's all the content that is on the test when we come back. Okay? Now we got to see if you can take some of what we've done and apply it. This is where sometimes we get a little lost.
Get there quick.
And we're going to be doing this a good part of the day.
Right.
Oh, no.
I know you're not in the hours. So how long are you we gotta be careful. Oh, yeah.
One for Jake on Elms Road. All right. Everybody have a paper?
You need to finish. I mean, I've got stuff laid out. I'm fine.
All right. I want you to look at question 44. Okay? And I'm not going to give you forever to struggle on question 44. But I want you to take about 5 minutes. And I want you to try to answer it. Now, before I let you loose, I want you to read the first line to me. What does it say? Indicate the second period element. That means that all of the answers have to come from where? The second period. So they have to come from one of the elements in that box. Okay? They have to be in that row. If they're not in that row, can it be one of those answers? No. Now, also, did it say every element has to be used as one of the answers? No. Did it say no answer can be used twice? No. So take those stipulations out. Don't assume that nitrogen can't be used twice, for example, or that every single answer in that row has to be used, because that is not the case. Okay? So read the questions and see what you can do before we do them together. Okay? And keep both of the ones we've used as well as your orange one with the numbers handy today, because we're going to float between the three.
We have to name it for each one.
So what?
You said that's maroon.
Yes. So you're going to find an answer for all A
But
through
there
G,
ain't no-
and all the answers are going to come from the second period. Yes. You're doing question 44. A through G. All the answers have to be a second period element. Okay? I want you to try it and see what you can do without me telling you anything first. Okay? I'm not going to give you long. I'm going to give you about 5 minutes or so. Some of you are going to sail through it. Most of you are going to struggle. And I know that. We just need a baseline of where we are. Some years we do better than others.
Thanks. Here.
Are we just doing 44?
Yeah,
Are we just doing 44 right now?
for right now. Got about 2 more minutes or so.
The first one was like that. The second one, no. The third one, no. What was the third one? Four. And five.
So I'm going to tell me what this number says.
So, how about number?
No, because they got some.
Yeah.
They got hands in this one.
Alright, let's see what you came up with. On your paper. So in question 1, it says, and you may want to make notes on this, because I'd say probably 25 questions out of the, I think the test is 63, about 25 probably look like this on the test. Okay? Contain a total of 4 electrons. What does total electrons mean? What do you look for when the question says total electrons? There you go. Okay? That tells you you need to look at the atomic number when it says total electrons. Okay? If I ask you for total electrons, I'm not talking about outer shell. I'm talking about the atomic number. Okay? So, if I say to you, which second period element, because I stipulated that in the directions, has a total electrons of 4, which element in the second period has a total number of electrons of 4? Who has 4 electrons? It's pronounced beryllium. B-E, beryllium. Okay? Now, look at the way number or letter B is worded. This time it says a total of 5 electrons in the highest main energy level. So what does it mean when it says highest main energy level? What? I heard it over here on this side. Outer shell. Okay? So that means outer shell. So, this time it said 5 in the highest main energy level, so it wants 5 in the outer shell, right? So, you guys know to say 1, 2, 3, 4, 5. So, who has 5 in the outer shell? Nitrogen. Okay, do you see the difference in the wording? Okay, did you make a note to yourself?
Yes.
Okay, because remember, you got to remember this Tuesday after break. C, contains a total of 2 electrons in the p sublevel. This is like what we did during the opening. P sublevel. P1, P2. So who has a total of 2 electrons in P? All right, D contains 3 half-filled Ps. Who has 3 half-filled Ps? Everybody good with that one? Enough people yelled out that answer. I feel good about that one.
I'm not. What is half PLP?
All right. So can we agree, Jay, that this is the P sublevel right here?
Yeah.
Okay. So all the way across would be filled, right? So this would be P1, P2, P3, P4, P5, and P6. So all the way across is P6. So it's half a 6. So who has P3?
Oh,
That's how we get it. Okay. So from there, has 3 dots in its electron dot symbol. So dots come from what again?
Outer shell.
So who has 3 dots in its outer shell? All right. The B, because it has how many electrons right there? 3. All right. Has 6 electrons in its electron dot symbol. Everybody go with oxygen?
Yes.
Yes? No?
Yes.
Some of my louder people who participate more are overriding my quiet folks. Do my quiet folks know how they got oxygen?
Yes.
Okay. And the last one has a filled main energy level. Neon. The filled main energy level is always going to be in what group? The noble gases. Why do we say filled sometimes instead of octet?
Because all the spaces have 2 electrons.
It was Andy's question yesterday. Does anybody remember what we said? Who's the exception? Helium. Helium only has how many electrons total? Look at your orange periodic table. It only has 2 electrons total. Can it ever have 8 electrons on its outer shell? No. So we call it full sometimes instead of saying an octet because it's never going to have 8 electrons in its outer shell. So we just say full. Okay? All right. I want you to try 45. Now, the difference in 45 is it says complete the following. Does it stipulate second period? No. So it can be anywhere on the table. Now, I need to correct C because it's got an error. So look at C. It says the number of occupied energy levels is. Beyond the period, right, the number of occupied energy levels is blank in chlorine. Okay? After the blank, write in chlorine. You got to have an element to work with. C. Got to have an element there. In chlorine. Okay? Do as many as you can between A and O before I stop you. Okay? Everybody got it? See what you can do. I'll be up bothering you in a minute here. These quizzes are pretty good, although some of y'all need to learn to spell. Darlene, I'm not what the number says. What's that say? 47? Okay.
Yeah.
All right, who's got a question? Y'all have had enough time to get started, get stuck, find something you need help with. You're stuck on everything. You're stuck on everything. You're what? Put your sweater on. All right, where you stuck?
Oh, I see it.
I got these two, but I don't know if they're right.
Yes.
They are right? Okay, well, I read the other ones and I don't know.
Let me look, let's go to the sub-level. How many blocks you got, or spaces you got across the S?
Like how many blocks there are?
Yeah. No, not down, cross. I mean, you got a cross.
Two.
That's easy. Two.
Which one? Which one?
Hey, start at the top.
What looks like a mid energy level contained.
Find the places on the periodic table that have twos. And count.
Taking like 2 electrons.
Nope. Like the 2 energy levels. Those are 2 energy levels. 1, 2. Here's a 2. 1, 2, 3, 4, 5, 6.
So 8.
Yep. That's also the one that you can use for probably locating anywhere.
The number of
The easiest way to do that one is draw a configuration and add up the energy levels. So, for example, you wrote the configuration for chlorine. How many energy levels do you have?
All that stuff is messed up.
That's the answer. Exactly. Okay, I got you started. Keep going. Who else has a question?
Me.
What?
Miss Wall, come here.
Element that contains a single 4s, where's 4s on the correct Which one is 4s1? No, it's at 1, correct.
I need help with I.
4.
Where?
He only has.
Oh, yeah. Easiest thing to do is draw overall notation and find out how many of them aren't 2 arrows. Find one that has 1 arrow. Now, the easiest way to do it is to do it shorthand and then just draw the end of it. So draw all of it in shorthand notation and just draw the end.
Okay.
That'll cut down your work. Same thing, draw shorthand notation. That way you don't have to start at one end. Okay? An octet, what do you think octet sounds like? Yes, exactly, it's 8. Who has 8? And is asking, the number of electrons containing orbitals in F, how many orbitals have electrons, like lines have electrons.
Oh my God, I can get my
All the permutations. Or if you get to the
And my head.
I recommend all the permutations and count. You're running.
Jamie, how was your day? Oh, good. Do we have a film with someone?
Ask if you have rolling. How many orbitals contain electrons? 1, 2, 3, 4, 5. They all contain electrons, so there's 5. Now, if you had one like here, let's say that you had a different element, and you only had, yes, like let's say you had something where you had just that. These two are empty, you say how many contain electrons? 3. It's asking how many contain electrons. All right, who else has a question? We get Justice number. A full third energy level. You can either use like 2 n squared or add up the electrons. I mean, yeah. There's a 3. There's a 3.
That's when y'all really
Threes are here. Squared and 3. What was that?
I give it at first. Oh. I think you call it.
No, I didn't write the worksheet. I got another text.
Hey, are we going
Talk to
to
the textbook baker.
You want us to keep going?
What?
Finish?
If you want to. We're gonna do it eventually.
They all going
Or G. The number of. Yes.
Jaden, did you finish your outline?
I just gave you a Saturday.
What's the point with
Just right. You can keep going.
Oh, yeah. He liked it. I said no. That's what happened.
Orbital notation of S contains how many more electrons. The easiest way to do it, like I did, I would just shorthand. That way you didn't have to draw all the arrows and then just look at it again and look how many of them are left there. But you need arrows to figure
That
out.
was.
Yeah. Huh? If you have any all passes left on you. Oh, never mind. Huh?
I don't know. We can't get the words that I've already got.
Hey, right? Yeah. You have 2? So that leaves you with 1. All right, you want to look at some of what you have?
Yes.
All right. So question 1. It says S has a maximum of how many electrons? Now, you can just remember the S sublevel, which is fabulous. But let's say you come back from Christmas break and you've had, there's Christmas break, Easter break. I'm on the wrong holiday. All right. Came back from Easter and you've had a serious, oh my God, moment. I can't remember. So I'll gave me this stupid test because she hates me and she wants me to fail. Okay? Because I do. I don't want you to fail. I want to teach y'all all again next year. So when you look at this and you're sitting there and you're struggling and you look at this S block and you go, how many does S have? So how many electrons can S hold?
2.
Exactly.
2.
That's the answer. Because S can hold 2, just like any S sublevel. The periodic table is designed to follow the quantum numbers. So if you forget, you can look at the periodic table, right? So if I ask you how many the P sublevel can hold and you have forgotten, you can count across the periodic table. P can hold, exactly, because the P sublevel is designed on the periodic table to mirror the quantum numbers that you guys learned, so you can just follow it. Okay? Now, let's say number B says a full second main energy level. And you're like, I don't know that. All right, some of you will remember 2n squared. And you can say n equals 2 and say 2 squared is 4 times 2 is 8, right? Some of you will have remembered, oh yeah, I could say 2 sublevels, 2p, and 2s, and I can say it has 2, and I can say 6, and I can get 8 that way. And some of y'all, again, are going to sit there and be like, this woman really hates me. Okay? So, how can you do this with your periodic table? Because you do not remember crap after Easter break. And you've got this multiple choice test, and you know all the wrong answers are the answers that you gave me in class, and so I made them fit on this multiple choice test. So, where are all the 2's on this table? That's right. So here's a 2. Here's a 2. So if you count up the 2's, 2 plus 6 is what number? Will it work for anything? It'll work for anything that exists on the periodic table. So if I said, if you had a 4th energy level, for example, all right, in a 4th energy level, you might remember how to use the 2n squared, but let's say you had a moment and you forgot. Where are all the 4's on the periodic table? Well, we got a 4 here, we got a 4 here, we got a 4 here, and we got a 4 here. So, how many is this? Here? Oh, you just totaled them for me. Okay, so 2 plus 10 is 12, plus is 18, plus 14 is 32. So if you forgot the formula and you don't know how to get it, you can add up all the 4's to get your answer if you forgot. Okay? See how I did that? Use stuff like that if you have a senior moment on the test on Tuesday and you just forget. Okay? So, C, the complete number of occupied orbitals in chlorine. How do we find occupied orbitals in chlorine? What should we do? What would you do?
Electron configuration.
I would. So chlorine is 1s2, 2s2, 2p6, 3s2, 3p5. So how many orbitals does chlorine occupy? Energy levels. It said energy levels. Okay? 3. This is an energy level. 2 is an energy level. 3 is an energy level. So it occupied 3 energy levels.
Why can't we just go down on the chart?
You could. What's the relationship between energy levels and the periodic table? Anybody figured it out? I didn't teach it to you. I was hoping you'd figure it out. I usually ask if anybody's got it. The energy level is the same as the period. And usually most people figure it out on their own, which is why I don't teach it. Okay? If you want to know an energy level, it's the same as a period. Okay? So since chlorine is in the 3rd period, what's its highest energy level? 3. All right, letter D. The electron dot symbol for aluminum will have how many dots? 3. E, the 3rd period element that has an octet. Who's the 3rd period element with an octet? A couple of people asked me an octet. What does octet sound like? 8. Okay, an octet is 8. So what element has 8 in the 3rd period? Ar, argon. All right, the number of electrons in the dot symbol for sulfur is 6. The outer energy level configuration for magnesium would be what? So after the noble gas, you would have what? 3s2. The full 3rd energy level would have how many electrons? 18. Again, you could do this is a 3, this is a 3, this is a 3, or you could do the 2n squared. So you'd have 2, you'd have 10, you'd have 6, which is 18.
Wait, so what's the answer to G?
G18. Oh, 3s2. Sorry, that was the one before that one. That's 3s2. I, the orbital notation for sulfur contains how many unpaired p electrons? It would be 2. How do you do that one? Did everybody get that one okay? Now, a lot of people, when it says unpaired p electrons, want to start and draw the entire orbital notation starting at 1s and do all of this. Do you have to draw all of this? You can do all of that if you want, but that's a lot, particularly if you have a longer element. I always recommend that you draw shorthand because everything in shorthand is full. Okay? So if it says how many unpaired anything, what's the only part that's going to be unpaired? What's the only part in this that's going to be unpaired? The very last one. This is the only part that you need to draw with the arrows to find out who's unpaired. Does that make sense? Yeah. This is full. That's full. You only need to draw 3p. So 3p has how many lines? 3. And you have 4 arrows. So 1, 2, 3, 4. So how many are unpaired? 2. That would be all you'd ever have to draw to get that answer. So you don't need to draw all those arrows out. Okay? Question number J. Which one would have 5 dots? Phosphorus. K. Which one of those will not exist? 2D. The element that contains a single 4s electron is who? Potassium. The number of inner shell electrons in phosphorus is how many? 10. We okay on those last 3? K is 2D. K. Sorry, I'm on the wrong one. J. What was it? 5 dots would be phosphorus. All right, so we're okay all the way through M. All right, so N. The number of electron-containing orbitals for fluorine is 5. Questions about how to draw that one or do it?
Yes.
Okay, so it wants to know how many orbitals have electrons. The easiest way to do it is to draw it. So fluorine has a configuration that looks like this. It's asking you how many, and Andy doesn't like the wording of this question, how many electrons contain orbitals in an atom of fluorine? He thinks it should say how many orbitals contain electrons. I didn't write the question. I'm sorry. Blame the book. Okay? It's a, I even forget the author of the book at this point. I think it was Modern. No, that's not the one I used. It's a different one. All right. So, how many orbitals contain electrons? This is an orbital. This is an orbital. They all have arrows on them, right? So, how many are there? There are 5. Now, if there was one that was empty, would you count it?
No.
No. And the last one for number 45, the number of unpaired electrons in arsenic. There are 3. So again, if you did that one, I would do it in shorthand. The arsenic is Ar, 4s2, 3d10, 4p3, P3, and I would only draw that. Okay? So it would have 1, 2, 3. So that would be unpaired. Questions? Think we can do a little practice with the plucker? Okay. No, I'm going to save the Kahoot for when we come back. All right.
Can't you just subtract 4?
Now, you're going to need your blue charts that are stapled and your periodic tables, because I am going to use some of our older stuff from way back at the beginning also. I'm not going to limit myself to just stuff we did today. Yeah, if you know your card number.
Yes, Jason. If I can grab it.
I'm going to grab my iPad. It's easier to scan the back.
Gotta go that way.
15, 14. Dang it, now someone took my clicker this time, Miss Wong.
Who's got Andy's card? Who's got number 5?
Oh, my bad.
Some sweet though.
Yeah.
But you know, so now.
Low and well.
All right. Does everybody have their cards?
Yes. Right. What you can get on one.
Right.
I don't know. Just give us a. And we be good to try.
All right. All right, everybody got it? Now remember, this is not a grade. Don't yell out the answer, people. It's not a grade. This is about helping you review for the test.
It's not expected it's going to be far. It's just the fact that it's going to be really fast.
All right.
That's the only reason.
So we got 12 rights and 6 wrongs. All right. When you look at your chart that's in front of you, you see where it says frequent or wavelength? Where it says longest wavelength, that means what? It means low frequency. Where it says high or short wavelength, that means what? High frequency. So who's down there with short wavelength? Violet. Okay? That's why we're doing this. Okay? Is this? Yes, it's going to be on the test.
Yeah, it's gonna be bad.
I need to fix this one. I need to put this on the answer. Oh my God.
You know I'm just doing myself.
Yeah, that's what I said too.
Because you know me anyway, but
I was so good. I was dressing it. She was like, how am I going to use the bathroom? We can go to
All right. That's just your hand is in the middle of the black. Okay. All right. So we got answer should be C. We got 2 people with the right answer. All right. The electron absorbs energy as it goes from the ground to the excited state, right? It does not give off light if it absorbs energy. Okay? It gives off light as it does what? As it releases energy. Okay? Here's an easy one for us.
Are you sure?
Yeah, let's rebound from that disaster. Yeah, let's rebound. We need to build some confidence here after that last one. I want 100% on this one.
Too bad, you're gonna get nice.
Oh, hold on, I got it wrong.
You really?
Yeah, I had the wrong side up. Yeah, but I hadn't scanned it yet.
Ooh.
I'm ready to move on.
Alright, so we got 17 to 1. Alright, phosphorus is not a metalloid.
I changed my
Alright, alright. If we have L equals 2, what's N? L equals 2, what's N?
Did you? Yeah, I think me and Allison were both out on the room for it. And that's what we're gonna do.
Oh.
Remember, you're not answering questions right now. We'll answer questions after.
Actually,
Am I rescanning?
nah, you don't have.
Alright, so we got 12 rights and 6 wrongs. Alright, Tomas.
And it's always one higher.
Oh, I put the wrong one. I bet
Okay.
I finally got some.
Oh, so
N is always 1 greater than L.
okay.
Okay? Remember, the sub-level is SPD. Okay? L is 2 is D. So if it's SPD, N is 3. But the easiest way is to remember N is 1 greater. Alright? Alright, how many electrons does group 15 need to achieve an octet?
Not really.
Okay.
It's really not as what we thought.
Okay.
I mean, it's bad, it's not as bad.
Alright, and you gotta stop shaking it and there you go. Alright. Justice is the only one I didn't get. Turn it towards me a little bit. Okay. Alright, so we got 17 to 1. If we're in group 15, we have how many electrons in the outer shell? So will we gain 3 or will we lose 3? We will gain 3. I have one person who got that wrong. Alright. Justice, your hand is clearly behind Tomas's. Tomas, put your hand down. Yeah, you can always walk this Blackwell. It won't stop anybody from scanning. So you're good anytime with that. All right, finally, we got 100 on that one.
Oh, I don't even know.
I know, I got it.
Nope, we finally got ones everybody's got right.
She's happy.
I don't even know how I got it right.
That's bottom.
Dang it.
Georg.
Santa Fe.
Yeah.
All right, I don't have Jonathan. I sent these. There we go. Got a weird angle on it. All right, we're at, looks like 9, 10, 10 to 8. 10 wrong, 8 correct. All right, the right answer is B. Half-filled d orbitals. All right, the fourth period. All right, would be in potassium's row, right? So potassium's row, half-filled D, starting at SC. SC, TI, VCR, MEN, FECO, NICU, and Z, and that, those, right? Count over 5. Thank you, sir. Count over 5. 1, 2, 3, 4, 5. MEN would be 5.
Next.
All right.
Yeah, no,
That's not what I was thinking.
I knew I was doing wrong, I guess.
It should be an easy one. I should have another 20 right. Or not 20. Yeah, it's 18. 18 people right.
Potassium is P.
Some people may choose that.
I don't know.
All right. And we'll order your hand. There you go. So your hand is in the black. All right. Yeah, 16 to 2. All right. Potassium's in group 1. So what's its oxidation number? Positive 1. How many empty orbitals are there in carbon? Empty. Empty orbitals in carbon.
Is there a, I don't know, answer?
There is not. For most of you, it would involve drawing it. Some of you may be able to do it without drawing it. I don't know.
I'm guessing.
Hold on. Some people are drawing it, so rest your arms. You're only doing 6 electrons. 2p.
I think I got it right.
All right. Shouldn't take you long to draw six.
I don't know, I'm scared.
It's not like we shoot you if you have the wrong answer.
It'll be wrong, and it'll punch you. That one's good.
All right. So we have 5 people right and 13 people wrong.
So how do you do it? What's the answer?
The answer is B.
Hey, I was gonna pick that
Hey, I was gonna pick that first.
1, 2, 3, 4, 5, 6. How many empty orbitals are there?
Ah.
I told you, you had to draw it. All right. 2 more questions. This one and then 1 more, we'll stop.
She always gives me this one.
This should be 100% right.
This is clicker.
It's the cheap version.
It's Lexington's version. This is the modern version. Look at that clickers about one.
I'm trying to get it, Freedom. Turn this way. There you go.
This is the last time I used it.
It's like 6th grade. We used to be standing right up at the board trying to click.
There, it's not gonna scan the big end. All right, so we've got 11 right and 6 wrong. So when you look at that, n equals 6 to n equals 2 gave you what number?
14.
14 gives you 4.1. 4.1 gives you 5 legs.
Move it.
All right, last one. All right, last one. 1, 2.
Oh, no.
What?
Oh, wow. Let me change my answer. Dang.
Justice. There you go, I got it. Yeah. Jonathan, turn it this way. There you go. All right, so we got 10 rights and 8 wrongs. All right, how many waves are there?
3.
Well, you can say 3 if you only stop halfway. All right, there's 3 waves in how many seconds? 3 over 1, which you can do, or you go all the way and say there are how many waves? 6 over what? So 6 over 2 is?
3.
So you can, the answer is 3 hertz.
I thought it was like in that little section right there.
Gotcha. If you will, bring me your flicker card and put it on my desk. Try to lay the number up so 4th or 3rd period can see it when we get to it. And then You don't have any homework this evening. You have no quiz tomorrow. If you're not going to be here next week, you will have to make up. Yes, you may. You will need to make up a lab because I'm really leaning towards doing that tomorrow.
Next week.
Well, when we come back, not next week, literally, the week we're back from break.
Might as well get that on your jacket.
And then y'all put your butts in a chair. We still have 2 minutes. Y'all know I can't deal with that standing up stuff.
Oh, man.
That's fine right there.